Let us take one more example of non-homogeneous differential equation, that is to solve d square y by dx square minus 6 times dy by dx plus 9y equal to 6 into e to the power 3x plus 7 into e to the power minus 2x minus log 2. This is a non-homogeneous differential equation, so we need to find solution in two parts, CF and PF. Now this equation can be written as d square minus 6d plus 9y is equal to 6 into e to the power 3x plus 7 into e to the power minus 2x minus log 2. Okay. Now first let us find the complementary function. The auxiliary equation is L of m is equal to 0. That is, auxiliary equation can be written like this. That is m square minus 6m plus 9 equal to 0. Now you observe this, since this is a second order differential equation, so this becomes auxiliary equation, becomes a quadratic equation. Now once it is a quadratic equation, again we need to concentrate on its constant term and coefficient of m. So first factorization is possible or not, we'll check here. They see we have to find two numbers such that if you multiply you must get a plus 9, if you add you must get a minus 6. Okay, so 9 is the number, so if you multiply minus 3 and minus 3, minus 3 and minus 3 are the two numbers where if you multiply minus 3 and minus 3 you will get plus 9, and if you add minus 3 and minus 3 you will get a minus 6. And also this is in the standard form of the form a square plus 2ab plus b square, so you can write it as m minus 3 whole square is equal to 0. Therefore m is equal to 3 and m is equal to 3, so are the roots. That is you got m is equal to 3 and m is equal to 3, because you can write this one as a m minus 3 into m minus 3 equal to 0. These are the two factors. Making these two factors separately equal to 0, you will get m is equal to 3 and m is equal to 3 are the roots. Therefore you can write this one as m is equal to 3 twice, repeated root. Therefore the roots are real and equal. Therefore the complementary function is written as y complementary is equal to, that is yc is equal to c1 plus c2 x into e to the power minus 3x. This is the complementary solution. Now we'll move on to the second part, that is finding the particular integral. Particular integral is given by yc is equal to 1 divided by LD of 6 into e to the power 3x plus 7 into e to the power minus 2x minus log 2. Now since this is a linear operator, we can operate it term by term, so we'll operate it first term by term, then we'll concentrate. 1 divided by LD of 6 into e to the power 3x plus 1 divided by LD of 7 into e to the power minus 2x minus 1 divided by LD of we'll write it as log 2 into e to the power 0x, because log 2 is a constant number which becomes a k, so it is into 1 means 1 can be written as e to the power 0x, so it can be reduced to the standard form. Okay, now we'll concentrate on this 3 here. Okay, first case, this is one separate case, this is one separate case, this is one separate case. So now we'll concentrate on this 3 here. Here a is equal to 3 is there in the first case when you consider this, but a is equal to 3 and is a repeated root, that is this root exists two times. Therefore according to the rules, what we have to do, we have to differentiate denominator two times, that is l dash of l of d two times, that becomes l double dash of d, that is l double, and after differentiation you have to replace it by 3. Okay, a is equal to 3, so l double dash of 3, so 6 into x square into e to the power minus 3x divided by l double dash of 3 with respect to first quantity. Now we will concentrate on this. Here in this case 7 into e to the power minus 2x is there. Here a is equal to you have 2. A is equal to you have 2, but it is not equal to the root, any of the roots here. Therefore directly we can use case number 1, that is 7 into e to the power minus 2x divided by wherever d is there in LD we have to replace it by minus 2. Okay, then minus log 2 is a constant quantity, keep that at as it is multiplied by e to the power 0x. Here in this case you can take a as a 0. Okay, if you take a is equal to 0, a is equal to 0 is also not a root of this equation. Therefore directly you have to replace wherever d is there in LD you have to replace it by 0. Now let us simplify this. So if you differentiate this, if you differentiate d square minus 6d plus 9, this is L. Okay, if you differentiate it to 2 times, it becomes L dash is 2 times d square minus 6, then L double dash becomes only 2, so it becomes 6 into x square into e to the power 6 into x square into e to the power 3x divided by 2. Now if you replace, in this case, if you replace d by minus 2, it becomes minus 2 square minus 6 into minus 2 plus 9. So in this case it becomes log 2. 0x is 1, so e to the power 0x is 1, we will ignore that. Wherever d is there, we will replace that by 0. That becomes 0 square minus 6 into 0 plus 9. So after simplification it becomes 2 1s are 2 3s are, that is 3 times x square into 3x. Then 7 e to the power 7 into e to the power minus 2x as it is. So this becomes 2 square is a plus 4 plus 4, see, minus into minus plus, that becomes a 6 into 12, 12 plus 4 is a 18, 18 plus 9, sorry, 12 plus 4 is 16, 16 plus 9 is a 25. So it becomes 7 divided by 25 into e to the power minus 2x. Now here it is minus log 2 divided by 0. This is 0, this is 0, then plus 9. So this after simplification this becomes our particular integral. Therefore the general solution of this equation, the given equation, is CF plus PI, which we can write as one as a phi of x plus xi of x, phi of x plus xi of x, which is written as y is equal to c1 plus c2x into e to the power 3x plus 3x square into e to the power 3x plus 7 divided by 25 into e to the power minus 2x minus log 2 divided by 9. This is the required solution of the given equation. Okay, now we have taken second order differential equations till now. Now we will move on to a little bit higher level, that is we will take a third order differential equations now. Okay, that is solve the differential equation d cube minus d square plus 4d minus 4 of y is equal to sine hyperbolic 2x plus 3. Now RHS is not equal to 0, as we know. By observing this equation we will come to know that this is the non-homogeneous differential equation. Solution is given into two parts, that is CF and PI. So first we will concentrate on CF. Therefore the auxiliary equation is L of m is equal to 0, that you can written as m cube minus m square plus 4m minus 4. Since this is a cubic equation, we cannot use Sridhara's rule or factorization method. Here we have to go for synthetic division method. But before going to synthetic division method, if you concentrate carefully here, we can simplify it, or we can extract one of the root without using a synthetic division method also. So here in these two terms, m square is the least term, m cube is there. So m square, if you take common, you left with m minus 1. So from these two terms, 4 is the common term. If you take 4 common, m minus 1 you left with. So from this quantity, if you take m minus 1 outside, from the first quantity you left with a m square. Here you left with a 4. So it becomes m minus 1 into m square plus 4 is equal to 0. These are the two factors. Now this is a quadratic equation. Okay. Now m is equal to m minus 1 is one of the factor, m square plus 4 is another factor. So m minus 1 is equal to 0 means m is equal to 1 is one of the root. M square plus 4 is equal to 0 means we can write this one as m square is equal to minus 4, or m is equal to, or m is equal to, you can write plus or minus under square root minus 4, which can be written as m is equal to plus or minus 2i. Therefore we understand one thing here, roots are real and distinct, and the two roots are complex in nature. Okay, two roots are complex in nature. Therefore with respect to this, the complementary function yc can be written as a c1 into e to the power x. Here alpha, that is real part, is absent, so we can write directly as c2 into cos 2x plus c3 into sin 3x. This is the required complementary function. Now let us go for the solution of the let us go for find the particular integral, that is denoted by yp is equal to 1 divided by ld of sine hyperbolic 2x plus 3. Now we don't have any standard formula, any standard form with respect to hyperbolic functions, okay, to find pi. So what we will do, we will use basic definition of sine hyperbolic function. That is, basic definition of sine hyperbolic function is sin hx is equal to e to the power x minus e to the power minus x divided by 2. In place of x, here you have 2x plus 3. Therefore using that basic definition, we can rewrite this one as, that is, we have to reduce this to the standard forms, any one of the 5 standard forms. So e to the power, using this basic definition, it can be written as e to the power 2x plus 3 minus e to the power minus of 2x plus 3 divided by 2. Therefore 1 by 2 is a constant quantity, you take that outside. then you can rewrite this one as 1 divided by LD of e raised to 2x into e to the power t minus e raised to minus 2x into e to the power minus t, so that you take this minus sign inside here. Next, what happens? E to the, here 1 divided by this LD is a linear operator, so we can operate it term by term here. So 1 by 2 times e to the power 3 is constant, you write that as it is. E to the power 2x divided by, you can write this one as a, L of 2, and minus e to the power minus 3 into e to the power minus 2x divided by L of minus 2, because here when you come to this case here, a is equal to, if you consider the coefficient of x here, a is equal to 2 is there, but a is equal to t is not equal to any one of the roots. Therefore, using that first rule, we can just replace to find the pi, we have to replace d by a in the L of d. And when you come to this case here, a is equal to minus 2 is there. So minus 2 is also not equal to any of the roots. So just we have to replace, to find the pi, just we have to replace d by minus 2 in case of this also. So it becomes 1 by 2 times e to the power 3x 3 as it is, e to the power minus 2x as it is. Then replacing this, this becomes 2 cube minus 2 square plus 4 into 2, 4 into 2 minus 4. Then in this case, e to the power minus 3, e to the power minus 2x into minus 2 cube, 2 into minus 2 whole square plus 4 into minus 2 minus 4. So if you simplify this, again rewriting this in the original form, you can write e to the, using theory of indices, e to the power 2x plus 3 divided by, it becomes 8. That is 2 cube is 8, 2 cube is 8, 2 square is 4, then 4 into 2 is 8, plus 8 plus 8 plus 16, plus 16, then this is a 4 minus 4 minus 4 is minus 8, 16 minus 8 is 8. Then in this case, so e to the power, it becomes both are with the negative sign, taking minus sign outside, and using the theory of indices, you will get e to the power minus of 2x plus 3. So after simplification, that is simplification, this becomes minus 8, then minus 8, then this becomes minus 4, then this becomes minus 8, then this is also minus 4. So you can write 8 plus 8 is 16, 16 plus 8 is 24, minus 24. So once again, 1 by 2 times e to the power 2x plus 3 divided by 8 as it is. Here minus divided by minus is plus, it becomes e to the power minus 2x plus 3 divided by 24. Now this is the actually required pi. Now therefore the general solution is written as y is equal to yc plus yp, that is y is equal to c1 into x plus c2 into cos 2x plus c3 into sin 2x plus if you take 8 common here, it becomes 1 by 16 into e to the power 2x plus 3 plus e to the power minus of 2x plus 3 divided by 3 is the required answer, or else directly this entire quantity we can directly substitute, which is the required solution. Okay, now let us take one more important example which has been asked in your VTU examination. Okay, it is solve d square plus 4, d square plus 4, sorry, d square minus 4 of y is equal to cos hyperbolic 2x minus 1 plus 3 raised to x. So this is non-homogeneous equation, already you know that, because it is not equal to 0. So we have to find solution into two parts. So first part, to find first part, first we have to write down the auxiliary equation. The auxiliary equation is L of m is equal to 0. That can be written as m square minus 4 is equal to 0. So or you can write it as in the form m square minus 2 square is equal to 0, whereas you can use the formula a square minus b square is equal to a plus b into a minus b. Using that formula, you can write this one as m plus 2 into m minus 2 is equal to 0, and making these two factors separately equal to 0, that is m plus 2 is equal to 0, which leads to m is equal to minus 2, and m minus 2 is equal to 0, which gives m is equal to 2. M is equal to 2. Therefore, m is equal to minus 2 and 2 are the required roots. These two roots are real and distinct. Therefore, since it's a quadratic equation, only two roots are required. So complementary function is yc is equal to c1 plus e to the power minus 2x. Sorry, c1 into e to the power minus 2x plus c2 into e to the power 2x. Now let us move on to finding the particular integral. That is yp is equal to 1 divided by LD of cos hyperbolic 2x minus 1 plus e to the power 3 to the power x. Now you observe here either this are not in the standard form, or we don't have any standard form with respect to these two. So what we need to do is using the basic definition of a cos hyperbolic function. Again, basic definition of cos hyperbolic function is cos hyperbolic hx is equal to e to the power x plus e to the power minus x divided by 2. But here x is equal to, in this case, 2x minus 1 is using this definition we can write this one as e to the power 2x minus 1 plus e to the power minus of 2x minus 1 divided by 2 plus this 3 raised to x. 3 raised to x can be written as e to the power x into log 3 using the basic definition of logarithmic functions. Okay. Now 1 by 2 is common. So this LD can be operated separately to the both the terms, So 1 by 2 is taken common. 1 divided by LD of, you can write it as, this is okay. First you'll take 1 by 2 common here, operate this LD to this, that's 1 by 2 times LD of e to the power 2x minus 1 plus 1 divided by LD of e to the power minus 2x minus 1, this is one quantity, plus 1 divided by LD of e to the power, you can also write this one as log 3 into x. Log 3 into x you can write. Okay. Once you write that one, let us go a little bit for now. You can observe one thing here. 2 and minus 2 are the roots. Now let us concentrate on the first quantity here. Here if you consider e to the power 2x minus 1, this is constant quantity. We need to concentrate only on the coefficient of x. Coefficient of x is 2 here, and that is equal to one of the roots. Therefore we can write the complementary function as x into e to the power minus 2x, x into e to the power 2x minus 1 divided by L dash of 2 plus when you come to this, you take it minus sign inside, minus 2, coefficient of x becomes a minus 2, that is a is equal to minus 2 in this case. A is equal to minus 2 in this case. Therefore a is equal to minus 2 means that is also one of the root. Therefore you can write here x into e to the power minus 2x e to the power minus of 2x minus 1 divided by L dash of minus 2 plus, I think it's not plus, it is plus log 3 into x, and here if you consider a value will become log 3, but log 3 is not equal to any of the roots. Therefore you can write using case number 1 L of log 3, that is wherever d is there in LD, you have to replace it by log 3 in this case. And here since 2 and minus 2 are equal to one of the roots, so in that case you have to find L dash, then you have to replace d by minus 2 or plus 2 as situation demands. Now 1 by 2 times x into e to the power minus 2x, x into e to the power 2x minus 1 divided by, it becomes 2 into 2 because L of d is d square minus 4. If you differentiate it once, it becomes 2d, then this is 0. So L dash d is L dash d or L dash is 2d. Therefore 1d is there. Therefore you replace in this case d is equal to plus 2. And here also same thing will come. You have to replace d by minus 2. Okay. Here it becomes 3 raised to x, again using it in the original, writing it in the original form, 3 raised to x divided by log 2 whole square, that is wherever d is there in this LD, you have to replace d by log 2 whole square minus 4. So if you simplify, you will get 1 by 2 times x into e to the power 2x minus 1 divided by 4 minus x into e to the power minus of 2x minus 1 divided by this becomes 4. That is here are written minus because plus divided by minus is minus. So it is plus 3 raised to x into log 3 whole square minus 4. So here from this you can take a x divided by 2 common here. X divided by 2 from this, x divided by 2 from this, so it becomes x divided by 1, 2 is already there, x divided by 2 into 2, it becomes x divided by 4. So you left with here 2, you left with the 2 here, 2 is the LCM, you can write it as e to the power 2x minus 1 minus e to the power minus of 2x minus 1 divided by 2 plus this term as it is. Now, by the definition of sine hyperbolic function, this quantity, this can be written as x by 4 into sine hyperbolic 2x minus 1, and this is plus 3 raised to x, 3 raised to x divided by log 3 whole square minus, for this is the required pi. Therefore, the general solution can be written as y is equal to yc plus if that is complementary function plus particular integral. So in the examination, writing this step at the end carries 1 marks, combining CF and PI. If you don't write this step, you may lose 1 mark in your examination. Okay, now we'll move to one more example. Okay. It is solve d cube x divided by dt cube, d cube x divided by dt cube minus 8x is equal to 1 minus e to the power t whole square, 1 minus e to the power t whole square. This is non-homogeneous by observation. So the given equation, see here one thing, till now we have solved it for y. Now this is x is a dependent variable, t is a independent variable, so we have to solve it for x in terms of t. So the given equation can be written as d cube minus 8 of x is equal to 1 minus t whole square. So where d by dt is capital letter D, d square by dt square is d square, capital letter D square, d cube by dt cube is capital letter D cube. Therefore, the auxiliary equation becomes L of m is equal to 0, which is written m cube minus 8 is equal to 0. Here we can use synthetic division method, but synthetic division method becomes a little bit more complicated here. So this can be written as in the form m cube minus 2 cube is equal to 0, and we already know that formula for a cube minus b cube. A cube minus b cube is equal to, we have a minus b into bracket a square plus ab plus b square. Now here a is equal to m, b is equal to 2. Now substituting this a is equal to m and b is equal to 2 in this equation, so you will get m minus 2 into bracket m square plus 2m plus 4 is equal to 0. So now this is one factor, this is other factor, which is quadratic factor. So make m minus 2 is equal to 0, you will get m is equal to as one of the root. Now since this is a quadratic equation, we have to concentrate on 4 and 2. So if you multiply, you must get plus 4. If you add, you must get plus 2. You have to find two such numbers for the factorization purpose, but here it cannot be factorized. So we will go for Sridhara's rule. That is m is equal to minus 2. That is here a is equal to 1, b is equal to have 2, c is equal to have 4. Therefore minus 2 plus or minus under square root b square means 2 square, that is 4, minus 4 a into c. A is 1, c is 4 divided by 2 times a. So after simplification becomes m is equal to minus 2 plus or minus under square root. See 4 minus 4 into 4 is 16, 4 minus 16 is minus 12. So it becomes under square root minus 12. So now this 12 can be written as 4 into 3. Okay, 4 into 3. Therefore under square root 4 is 2 and root 3 as it is. Root 3 into 1 is root 3 into under square root minus 1 is root 3 into I. So it will become a complex form. So now taking this denominator separately to this or doing cancellation, you will get 2 ones are 2 ones are 2 ones are 2 ones are. You will get this root as minus 1 plus or minus root 3 I. Okay, minus 1 plus or minus root 3. Therefore we got 3 roots. One root is real and other 2 roots are complex in nature. Therefore the complementary function yc, the complementary function yc is written as c1 into e to the power 2x plus e to the power minus x, because alpha is minus 1 here, into c2 into cos root 3x plus c3 into sine root 3x. This is the complementary function. Now let us concentrate on finding the, I'm sorry, here in this case we are solving it for I'm extremely sorry, we are solving it for x. So it becomes x is equal to e to the power e to c1 into e to the power 2t, then e to the power minus t into c2 into cos root 3 root 3 into t, then c3 into sine root 3 into t. I'm extremely sorry. Just we need to concentrate on the variables when we are solving. Okay. Then next, to find pi, yp is equal to 1 divided by LD of 1 divided by LD of this is 1 minus e to the power t whole square, that is 1 divided by here it is not in the standard form, so using a minus b whole square formula you have to expand it and then we have to apply whichever the formula is applicable, that is 1 divided by LD of a square, that is 1 square, and as it is minus 2ab, that is it becomes minus 2t plus e to the power 2t. So now operating this separately, this 1 can be written as e to the power 0t, 1 divided by LD of e to the power 0t, then minus plus into minus is minus 2 as it is constant term, 1 divided by LD of e to the power t, plus into plus is plus, 1 divided by LD of e to the power 2t. Now coming to this part here a is equal to 0, but a is equal to 0 is there, a is not equal, that is 0 is not equal to any of the roots, so directly you can replace wherever d is there by rule 1, wherever is d is there you have to replace directly by 0. And when it come to the second case, it is only e to the power t, so it means a value is 1 here, so 1 is also not equal to any of the roots of the auxiliary equation, so directly you can write L of 1. Now when you come to this part, so it is e to the power 2 to there, but m is 2, a is equal to 2 is one of the root, so according to the rules what you have to do, you have to differentiate denominator once you differentiate denominator once, you have to multiply it by 1t, that is t into e to the power 2 divided by L dash of 2. Therefore here L is d cube minus 8, therefore L dash becomes 3d square, which this is 0. Okay, now this becomes e to the power 0 to means 1, I'll write that as it is, then 1, then 0 cube minus 8 minus 2 divided by e to the power 2 into e to the power t divided by wherever d is there you have to substitute 1, that becomes 1 cube minus 8 plus t into e to the power 2t, then L dash of 2 means 3 into 2 square, so it becomes minus 1 by 8, so this becomes minus 2 divided by e to the power plus t divided by plus 1 minus it is minus 7 plus t into e to the power minus 2t, 2 square is 4, 4 into 3 is 2 square is 4, 4 into 3, I'm sorry, 4 into 4 into 3 is this becomes actually 12, 4 into 3 is 12. Okay, done. Therefore this is the required p. So now we can write this one as this is, I'm sorry, little bit confusion, 4 into 3 is 12. So the general solution is given by yc plus yp. Okay, yc plus y, that is c1 plus c1 into e to the power x plus e to the power minus x into minus t. This is also you can write it as t, e to the power minus t, the c2 into cos root 3 plus c3 into sin root 3 into t into e raised to 2t divided by 12, then plus this minus divided by minus becomes plus 2 by 7 into e raised to t minus 1 divided by 8, which is the required solution.